Hello, welcome back friends. As we have seen into our previous video, what is the concept of the LVM, that is our logical volume manager. So as we have seen the concept of the LVM, we will now see the exact implementation of the LVM. That is, we will see how to see the information about it, how to create actual LVM, and how to manipulate it. Everything is having different commands. Now in this video we will first see how to gather the information about our existing LVM layout. Now for understanding this, we have one scenario in front of us, and let me read the scenario first. So this is what the scenario we are having in front of us, that is our LVM is the LVM implemented for your any partition. We have to find out first, is any LVM implemented there? And if the LVM is implemented, if yes, find out the following information. So what kind of information we need to find out? As we have seen in LVM concept, there is a physical volumes, there are logical volume groups and logical volumes too. So we will first find out the information about the logical volumes, in which we have to find out this much of information. After that, we will find out the information about our volume groups, in which we will find out this much of information, and finally we will find actual logical volume information. Everyone has its own commands. Now while going this, by the taking of the reference our previous video, we will first see the physical volumes, how much physical volumes are there in our system. Now let me switch to the another terminal where I can fire my commands, and let me clear up my screen. Here, first of all, I want to see how much physical volumes are there in my system. To get the information about the physical volumes, we have to fire a PV display command, that is PV display. So this command will show us how much PVs or how many PVs are configured in our system and their related information. So hit the enter, and this information is in front of us. That is, first is PV name, that is DEVSDA2. so this is our second partition of our hard disk, DEVSDA. This is our second partition, that's why it is having naming convention as /DEVSDA2. This comes under the volume group, which is having a name VG. VG is the name of our volume group. Next to it is PV size. How much is the size of our PV, which is displayed into the gigabytes, that is 6.96, means nearby 7 gigabyte. It is allocatable. Its PE size is 4 MB. And now we gotta see a total physical exchange. As we have seen the concept of physical exchange in our previous video, that is, physical exchange are small chunks of the volume group. So here the total PE is 1780. This is our total physical exchange size. From that, if we going to see the free PE size, that is free physical exchange, that are 152, and allocated PEs are 1628. Every partition is having its universal unique identifier. So our PV is also having a universal unique identifier, that is UUID, and this is its UUID. So this is what the information about our PV display. This is what the information about our physical volume. Here we just having only one physical volume, that's why it is given us DEVSDA2, means one physical volume. If you have multiple, it display every physical volume which is configured into the system. So our first goal is achieved, that is getting information about the physical volumes. In that we have seen name of the physical volumes, that is what our PV name, and also we have seen sizes of all physical volumes. So as we have only one physical volume, so this is the PV size. So our both of the goal has been achieved to get the information about physical volumes. Now we will move towards our next section, that is volume groups. Now we are gonna gather information about our volume groups. In that, first of all, we will see the information, that is what is the name of our volume groups, or how many volume groups we have. Again, I get back to my previous terminal. I'll clear the window Okay, and now I will fire a command which will give us information about our volume groups. So that command is VG display, and after hitting the enter I have one VG, so it displayed me the VG name, that is volume, what is the volume group name, and our volume group name is VG. VG is our volume group name. So our first goal, our first task is complete, that is finding out the name of our volume group. Next we have to find out sizes of all volume groups. So here I need to see the VG size, that is volume group size is 6.95 GB. So this is what the size of volume groups. By using this command you can find out the size of any volume group. You just have to see the record, that is VG size is VG size record, that is what the 6.95 GB. Now next to it we have another task is sizes of the physical extent of each volume group. How much size is of the physical extent of the volume group. So here just come to the PE size. So the PE size is 4 MB. So we have 4 MB of physical extent of this VG, of this volume group, which is having name as VG. Okay, now next to it, the next information, how much of the free space is left in each volume group. That is also an important thing. In order to resize the LVMs or create the logical volume, we must have to know how much of the free space is there in our volume group. So that can be displayed by this same command. Here into the free PE size, it shows how much of the free space is there of our volume group. So nearby 608 MB is free. The leftmost side of this, left hand side of this, is displayed into the extent, that is 152 extent are free, and the rightmost side it will display into the MB, that 608 MB is the free space or free sizes of our volume group VG. So that's what the getting the free space in the volume group. And finally we will see that is how many extent are free in each volume group. So that is what, how many extent are free into the volume group. So these are the same one, that is 152 are the physical extent that I have already explained. That is physical extent are 152, and how much the free space, that is in MB, is 608 MB. So both of it is displayed in only one record. Okay, now this is what the information regarding our volume groups, that is this much of information that we have find it out. Now we will turn towards our final section or final component of logical volume manager, that is logical volumes. So here we will first of all find out the information, that is what is our names of what are the names of our LVs that the VG they belongs to. So here let me come back to my terminal again and let me clear up the screen. And now to get the information about the LVs, we need to fire a command LV display. Once I do this and hit the enter, so I am having a huge output here which shows me the information about each and every LV which is configured into the system. So that is what the command I have fired, and here is the information about each and every logical volume. So first of all that we have to find out is what are the names of our LVs. So the first LV is /tev/vg/lv_root. So the LV name is lv_root, which comes under the volume group VG. Next is second LV, that is /dev/vg/lv_home. So this is our second volume group, which is /lv_home, and which also contain or which also comes under volume group VG. Next we are also having one more LV there, which is having name LV swap, which also comes under the volume group VG. So our final LV is /dev/vg/lv_swap. So these are the names of our LVs. Sizes of our all logical volumes. So in their sections there is a one field, there is one record is LV size, which shows us the size of that LV or that logical volume. So the first logical volume, that is DEV VG LV_root, is having LV sizes of 5.37 GB. Next, our next LV is /DEV VG LV_home, which is having LV size of 500 MB. And our final logical volume, which is /DEV/VG/LV_swap, is having 512 MB of the size. Now, as we have completed our second requirement, so the final one is finding the mount points for each logical volumes if they are mounted. So here we cannot see their mount points. So for watching the mount points, we have another command, that is df-h. If you hit it, so you will get that the /dev vg lv_root is mounted onto the slash partition, which is the main directory of our Linux directory hierarchy structure. And our second LVM, that is lv_home, is mounted onto the /home partition. Okay, by utilizing this command we are not able to see the final LVM, which is the swap, lv_swap, because lv_swap, to see that we have to fire a command as by guessing its name. I'm firing the command free swap on -s. So it is showing me dm-1 means device manager. So regarding the swap, we will see into the next video. Okay, so here we have seen that is our two LVMs are mounted onto the directories which we actually use for storing the data. So by firing these commands, we are completing our goals to getting information about physical volumes, volume groups, and logical volumes. Now this we have seen getting information about them. Now in next video we will see how to create them. Okay, so till then, have a good day.